Tim, if we have you on the line, as it were, I should have given you remote control of the screen and you should be able to go ahead.
All right, can you hear me?
Yes, I can hear you just fine.
All right, fantastic. So, thank you, IFE's technical committee for having me speak today, and thanks to David Reinhardt for volunteering me and letting me out of my cage to talk to you guys today. So I'm a lead engineer at Kamika. I've been there 18 years now, starting with Imago and now Kamika. And currently I'm the architect for our new AP Suite software, Atom Probe Suite software. We just released our 6.601 version, and we talk about one of the new features in 601, which is custom analyses. So moving right along, let's see if I can advance the slides here. All right, so it's both my philosophy and Kamika's philosophy that we want to embrace the Atom Probe community's independent efforts for running Atom Probe analysis software. As you probably all know, there's been a long history of people writing independent programs. I've been to lots of talks where people are doing the same thing in different languages in different parts of the world, and there's not a lot of sharing going on. So we're, along with you guys, of course, the technical committee, hoping to try and pull in some of that effort online so we can all leverage each other's work. So the first thing that we've done here is made a new feature in 601 called the custom analysis. So this is what we have right now. It is just a first start into this world of embracing external analyses. If we waited till it was perfect, of course, we would never release anything. So we really are excited to get this out in the world and get some feedback. So this new custom analysis feature is a custom module. So it's a DLL that you build, and the software loads it on startup and adds new menu items into your analysis tree. So you right-click anywhere in the tree like you normally would for adding nodes. You can find new custom analysis nodes in the list. Those are built at startup from analyzing the modules that are available. And the modules then, these custom analysis modules, have access to the data in your reconstruction. So that would be the raw ion position, XYZ, mass to charge ratios, the ion type, the identified type, which would be, say silicon or iron, and also the range data which is used to generate those ion types. And because these modules are just normal DLLs, you can call any external code you like. You could call a Python, external Python script, all quite easily. We did try, actually, in our previous version, 6.0, having a raw C# console in AP Suite. And we've actually taken that out in favor of having these external DLLs, because it turned out that editing code, C# code directly in AP Suite was difficult without having all the tools available to you from an IDE, like code completion and inspection. So everyone was using Visual Studio anyway to edit their modules. So we decided just to make it fully into the Visual Studio world. So you can still add a C# console. There's a special type of external module. It's called a, if I remember correctly, a custom analysis with console, and then you can have your C# window if that was a way that you'd like to do it before. So moving on here, here's an example of a custom analysis user interface. On the left side is an automatically generated UI for editing the parameters of your module. All you have to do in your module is list the parameters in a class. It's called the options class, and they will be automatically shown here with the defaults. And then you can, of course, change those defaults if you like. And those values, those parameters, will get saved with your analysis tree or your analysis state. And then when you click run, It calls a function in your module called run that does whatever processing you like. And there's a thing called a view builder that the interface is passed into your run function, which allows you to use the built-in visualization tools in AP Suite for outputting your data. So there is text and tabular data. The example here on the right side is tabular data. In this case, some compositional information. And then we can also have a few different types of visualization. You could have 2D plots, both line and histogram types of plots. And of course, histograms, you can do linear and log, you can change binnings and that sort of thing. And you can have also like a graphical heat map, color map type plot, which is shown on the right there. And you can have a more standard Atom Probe software 3D view with whatever data you'd like. And you can also add points. You can add points and surfaces to that 3D data. And the interface for the view builder is very, very easy to use. It was meant to be very easy for the users to add new visualizations. So those modules that I showed a few slides ago in the right-click menu, all those are in one DLL. The source code we distribute with Atom Probe Suite. It's a zip file that lives on your machine after you've installed Atom Probe Suite. You can see that here. User, I've asked custom analyses zip, unzip that to in the directory of your choice, and you can open that with Visual Studio. There's a solution file in there. You can open that right up and check out all the source code for those examples. The examples are simple, and they provide some good examples of how to use things. So unfortunately, we do not have, at the moment, a documentation package for our API for these modules. Again, if we waited till that was ready, we'd never would be late. So we've provided these examples instead. And the beauty of .NET C# code is that you can inspect all the available functions that you can get from our API. So you can use what's called the object browser, and you can see all the various functions you can call. And the examples show example use of those functions. We will have more documentation later, but it's right now the examples are what we have. So after you build, you get a DLL, and all you have to do is copy that back into your Atom Probe Suite installation folder, restart your app, and the module will be loaded, and it will appear in your custom analysis menu. I also want to talk about our APT file format, which instead of sticking with POS and EPOS for our reconstructed data, we've moved to this new format called APT. I wanted to have a format that was expandable. So instead of having a fixed number of records in the data file, now you can add as many what we call sections as you like to the end of an APT file. And the format is very clear, and there's nothing weird. You can use any type of language to read and write it. And the sections are arbitrary. They don't have to follow any known standards. We have our own standards for position, mass, that sort of thing. But you can also add things from your custom analysis, like some new phase information, say, or local density, or something of your choice. Full specification is in our user guide, and I will have this available if you contact me, or you can find it online. Eventually, we're working on having a new home for all this stuff. So this is the exciting stuff. What's coming next? So I said before, this is just a first pass in AP Suite 601 on our next release, which is coming hopefully right away next year. These custom analysis modules are going to get access to a lot more data, so including other things in the analysis tree, like any other analysis you might have, like concentration data. You can also see the 3D concentration grid or isosurfaces from other nodes in the tree. And also you can get access to any type of raw data available. Right now, you can just see kind of your standard POS data, XYZ mass. In the future, you'll be able to see any of the things on the right side of the screen here. Also, we're adding a lot of new visualization options. So you can see arbitrary data from your APT file. So if you add new APT data items, you'll be able to visualize those without having to write your own visualization code. You can also generate data from a custom module, which I think has a lot of pretty cool opportunities. And for things like creating a little mini simulator right in the middle of your analysis tree, or doing some custom filtering. So once you have a custom analysis node, you'll be able to right-click on that and add any normal analysis like concentration or isosurfacing, like you would any other ROI in our software. And we're also going to have a new type of module, a custom reconstruction module or custom reconstruction scripts, so you can do your own reconstruction algorithms or automate some of our existing reconstruction wizard steps and parameters like K-factor. And we're also going to have, hopefully, some sort of online integration where if you have a GitHub repository, you can point AP Suite directly at GitHub and automatically download custom analysis code right to your computer without having to do it manually. And we're hoping we can start to have a online repository for people to submit open source modules where people can share different ways of analyzing their AtomProbe data. So that is all. Thank you so much to the committee for having me. Especially also thank you to GPM for providing some of our examples and helping us define and evaluate our custom module interface. So are there any questions?
Okay, thanks, Tim, very much for an excellent presentation. So should mind everybody to please put your questions. So we've got a question from Ben Kaplan's. He says he can see that TOF and TOFB is on the APT file branches. Can you just speak to what the difference between those two are? I guess he's trying to ask what sort of rawest form of data that you have available is.
Sure, TOF, let me pull it up on my TOF is raw TOF. TOFB, I believe, is bowl corrected time of flight. So like flight path corrected time of flight.
Okay, so would you say that the TOF therefore is the rawest form of data that's available from the
correct? So like the rawest form, if you wanted to do very basic reconstruction, you would want time of flight, voltage, and detector X and Y, quite similarly to the last talk, Patrick's talk.
Okay, thanks very much. I just have a quick question myself, actually. In terms of interchange between different labs, I mean, how does Kamika see? I think currently people are mostly passing around our hit files between the labs that have Kamika-based instruments. How do you see interchange of data going forwards for lab users?
That's an excellent question. Our new software has an export function, which will export all the data from experiment through reconstruction to analysis, where it kind of creates a package of your RHIT file. Well, now we have a file format called hits for the raw format, which is actually a closed format. But if you do a reconstruction with these extra APT branches, then the APT file then is also included in this export format. And the APT file would be where you would have your all of your raw data that you would like. And then for the analysis section, that is stored in an XML file, and an XML file can be imported using APT Suite, and will let you see your analysis tree on different machines.
So therefore, for data reporting, you might see this format being the format you might report coming out of an experiment, potentially.
Right, yeah. Yeah, for that, so for FAIR, for instance, I would assume that you'd want to have that entire data package available online. All right, any more questions?
So I had one. I can't use the Q&A function very easily as the host. Do you have any? Can you comment on whether the custom modules run as fast as the built-in modules, or is there some kind of speed penalty because they're custom code?
They will run as fast as the built-in modules. Yeah. Yeah.
Great.
I mean, obviously, if you need, you would have to do your own multi-threading, for instance, if you wanted to take advantage of a large CPU or something. But in terms of access to the data, we do this thing called memory mapping. So that the APT file is memory mapped, and so when you call into the function that you get in your run gives you a pointer to that memory, and you get so because it's memory mapped, it's extremely fast in terms of the I/O of the raw data itself.
That's great. Thank you very much.
Yeah, so I think we have a few questions outstanding at the moment. So users who are still working on getting their questions together, just do that now. But I think we had a question from Andrew Prudian that relates back to some of Tim's stuff from Kamika.
Yeah.
Does the APT file format contain all of the data that resides within a hits file? Tim, if you're still there, there's a question for you.
Yeah, I am still here. I actually responded privately to that one, but I'll respond for everybody here. Optionally, you can add almost anything from the hits file to the APT file. It's optional, so you don't have to waste disk space for data that you don't actually care about in your reconstructed data. And there are some internal debugging type things that you can't put in the APT file, but in general, all the things that anybody doing research on Atom Probe would need are available.
Can I ask a question off the back of that, Tim?
Sure.
Is the timing information available there? So not just the XY time of flight, but the unresolved timing information?
That's actually not even in the hits file, so
okay.
So no, it is not available.
Okay.
Yep.
Thanks. Thank you very much. I think with that we'll possibly need to move on.
All right.
But thank you very much for that. That's excellent. So